All right, so really, the things that you need to know, all right? And I don't know if you want to put this on the back. I mean, you should already have it written down, but just as a review, if you want to put this on the back or somewhere. So to identify what type of reaction you have, so if you have a single compound as a reactant, what type of reaction is that? Single compound is decomposition. Okay? So look, these are things that you need to memorize. Okay? You need to know that like when a reactant is just a single compound, it's decomposition. Okay? What about if it is an element reacting with an element? That's a synthesis reaction. Because the two elements are just coming together. What's the other word for a synthesis reaction? Combination. Okay? What about if you have an element reacting with a compound? That's single replacement. And then if you have a compound reacting with a compound, that is double replacement.
Why do I hear Christmas music?
Yeah, turn the music off.
You said it was quiet.
All right. And the last one, if you have O2 and some combination of carbon, hydrogen, and oxygen. Okay? What is that? That's combustion. Okay?
So it's O2 plus either C.
It's O2, and it's either going to be carbon and hydrogen, or carbon, hydrogen, and oxygen. So depending on the compound. I mean, if you look at like...
Basically, oxygen plus anything is combustion.
No, it's not oxygen plus anything. I mean, think about this. If you have this reaction right here, if iron reacts with oxygen, what do you get? You get rust.
Yeah, that'd be single replacement, right?
Okay? This would be synthesis. It's an element reacting with an element. Okay? But that's not combustion. Like, you've never seen fire with a rust reaction. Okay? That's not combustion. That would be a synthesis or combination reaction. So not every reaction with oxygen is combustion. It's really only reactions that involve some type of fuel, which carbon substances are generally considered like fuel sources. Like gasoline is a carbon-based substance. It's octane. Octane has 8 carbons in it. So those are combustion reactions. All right, now look at the front. Okay, and we're looking at letter A. Lily, did you get that printed off all right? Okay. So letter A, you have the reactants written out. Now, this already tells you that it's combustion. The way that you know that it's combustion is because you have a 6-carbon substance with 12 hydrogens and it's reacting with oxygen. Okay, this is something called hexane. All right, and it's reacting with oxygen. Now, let's assume that this is complete combustion. If it's complete combustion, what are your products? Ben?
Carbon dioxide and water.
Carbon dioxide and water. Okay, so complete combustion always has the same products. Carbon dioxide and water. Now, is this balanced? Nope, that one's not balanced. So you can balance that one. I'm just helping you predict some of these products.
Do we have to balance it?
Yes. All right, letter B. Let's assume that this is incomplete combustion. What are your possible products for that one? All right, it could be carbon monoxide and water, or just carbon and water, okay? It's probably going to be some combination of those, but let's just put carbon monoxide and water for this one. And then the third one, letter C, this is your other combustion one. Let's assume that this is incomplete, and let's just put carbon and water for your products. All right? So don't be surprised if, like somewhere along the line on a quiz or test or something like that, you get asked what would be the products for complete combustion. In that case, it's going to be carbon dioxide and water. If I say what are the products for incomplete combustion, then you have a choice of either carbon and water or carbon monoxide and water. Jimmy?
So can all these answers be flipped around?
What do you mean?
Like, couldn't you put the CO2 plus water for part B and C as well? Just since you want to showcase the.
Well, it depends on if it's labeled. If I tell you it's complete, it has to be carbon dioxide and water. If I tell you it's incomplete, then it's going to be
Like a mixture of.
one of these two. I would just pick one, but in reality, it's probably going to be a mixture of more than one. I mean, guys, here's the thing. You got to understand, in an actual chemical reaction, in real life, you're probably going to have a mixture of all three of these. Because, I mean, if you've ever burned a candle before, okay? A candle is just a hydrocarbon compound. It's a hydrogen-carbon compound. All right, that's what it's made of. A long carbon chain is what candle wax is made of. So when you burn that, you've seen black stuff come off there, right? Anybody ever seen black soot come off of a candle before?
Yes.
Okay, all right. So that's carbon. Okay, it's carbon. Now, we know it's not all carbon, because it's not all just black stuff just billowing off there. So there is some carbon dioxides coming off there, and there's probably even a little bit of carbon monoxide coming off there also. Okay? So it's going to be a mixture of all three in reality, but that's really hard to write on paper. So that's why, normally we will indicate, well, is it complete combustion? Is it incomplete? Because some things will be more complete than others. Like, if you look at this is a fairly large compound. It's got 6 carbons, 10 hydrogens. That's harder to burn than something that's got 4 carbons in it. It's a smaller compound. So smaller compounds are easier to burn than really large compounds. Okay? Anybody in here drive a diesel? Actually, you guys don't drive. Anybody here's parents drive a diesel? Diesel truck? All right? So, Macy, which takes longer to start up, a diesel or a gasoline-powered vehicle? Do you know?
I'm gonna take the gasoline.
No.
No.
Wait, longer?
Why would he
Longer.
ask that if it was gas?
Longer.
I was thinking shorter.
Longer, a diesel engine takes longer to start up, and the reason is because diesel fuel has longer carbon chains in it. It's like each compound, each molecule that's in it is a longer chain. So it's usually a little bit thicker, okay, the fuel is. So it takes longer to be able to start that up, to be able to burn that fuel. Now, it normally burns longer, but it's also going to take longer to get started burning. So you got to think about that also. Now, diesel fuel tends to burn a little dirtier too, because it's a larger compound. So a lot of times you're not going to get a fully complete combustion when you're driving a diesel vehicle. Okay, you don't get a full combustion with gasoline either. But it's probably going to be a little bit more incomplete with a with a diesel engine.
Aren't like diesels like, wait, what's the difference between one and the starting one? Like our diesels?
Well, I mean, it's two different types of fuels.
I know, but like, what's the point? Like, what's one?
Diesel gas costs more, right?
Not necessarily. It fluctuates.
Is like diesel more powerful?
Normally,
For bigger trucks, it's like for bigger, like a big.
that's not always the case. So diesel, I would say, more of your diesel vehicles are probably going to be larger, like bigger trucks. But I mean, my mom drives a Volkswagen Beetle and it's a diesel. So some of your European-made cars will be diesels. A lot of your American cars are not diesel-made, unless they're trucks. But it's just the process of making it. Like, it's a different type of fuel. So, you know, when you pull up to the gas pump and you see like the super, the premium, the unleaded, you know what I'm talking about?
Yeah.
Okay? Those are different types of fuels. They all have a little bit different formula, and they all have a little bit different something that's been done to them. Normally, they'll all have a little bit of mixture of, if it's gasoline, it's octane mostly, and then a little bit of usually like some ethanol fuel added into it. It really just depends on how much. That's really what makes your different types. Like if you've ever seen E85, you've seen that before at the gas pump. The E85 is usually like, I think 85% 85% octane and like about 15% ethanol, which is mostly made from corn. So,
Yeah, I know.
yeah, it's kind of a side topic, but there you go. All right, now back to our examples here. So, number one, you know that this is a synthesis reaction. And the reason you know it's synthesis is because you have an element reacting with an element.
And it says.
Okay? And it says, everybody know that a diatomic element is still an element, right?
Yeah.
Okay, so Brinkelhoff, all of those are considered elements whenever you're identifying your reactants, to be able to tell whether or not it's what type of reaction that it is. So to be able to predict the products, all you're doing is just smushing the magnesium and the iodine together. Now, what kind of compound is this making? Ionic or covalent? What's magnesium?
Magnesium.
A metal.
That's ionic.
This is ionic because magnesium is a metal and iodine is a nonmetal. So you have to crisscross the charges, which magnesium is a +2. Iodine is -1. So when you crisscross the charges, magnesium gets the 1, iodine gets the 2. So this one actually comes out balanced. But that's just a coincidence. Okay? It's not because it's like a special substance. All right? Okay. The next one is double replacement. And what you have right here, your cations are going to switch places. Now notice, both of these are ionic. Metal, non-metal. Hydrogen is not a metal, but it's still on the metal side. So this is kind of loosely ionic, all right? But regardless, the hydrogen is going to pair with the chlorine on this side. Hydrogen's +1, chlorine's -1. And the copper is going to pair with the sulfide. What's the charge on copper here? How do you know it's a +2? Ben? How do you know?
Because the chlorine has a 2 on it.
Right, the chlorine has a 2 on it, and the chlorine is -1. So you need 2 -1s to cancel out 1 +2. So the copper is +2. What's the charge on the sulfide ion?
2.
That's a -2. So that comes together in a 1-to-1 ratio. that's going to be HCl plus CuS. That's not balanced, but it's pretty easy to balance. All right? Everybody with me so far?
Yes. I mean, kind of, pretty much, yes.
Okay, I'm going to skip some of these. I'm going to skip 3. I'm going to skip down to number 4. Now, on number 4, this is a decomposition reaction, and I would have to give you one of the products because there's actually 3 elements, so you don't know exactly where it splits. So, one of the products is going to be calcium oxide, CaO. What is the other product? Just subtract the calcium and 1 oxygen. What do you have left? You have carbon
Dioxide.
and 2 other oxygens. So you have carbon dioxide. That's your other product.
Well, look, Mary was right.
That one's already balanced.
Well, I actually said it first, so.
Sadie and I were such.
All right.
Sorry.
Now, we're going to do a couple more of these together. I'm going to do some of the ones where they are not identified as to what type of reaction they are. So take a look at number 6. Is sodium an element or a compound? That's an element. And then what's magnesium chloride? That's a compound. So what type of reaction is that? Single. Single replacement. Does everybody see how I got that there? I look at the 2 reactants. It's an element reacting with a compound. That classifies as a single replacement reaction. All right, now, in a single replacement reaction, one of the elements is going to replace the other. Okay? Now, I'm going to make this statement. I'm probably only going to make this one time. I am not going to force you to do this right now, but I just want you to know this going into chemistry here in a couple years. Not all single replacement reactions actually take place. So some single replacement reactions, you may bring the 2 substances together and they do nothing. Okay? And here's why. There is a table of reactivities. It's an activity series is what it's called. Elements that are higher on the table will replace elements that are lower. Elements that are lower will not replace elements that are higher. So what you would have to do right here, the 2 elements that are in consideration, since sodium is a metal, you would look at the metal in the compound. If sodium is above magnesium on that table, that reaction will take place. If magnesium is above sodium, nothing will happen. Okay? So, as of right now, you're just going to assume that all single replacement reactions do take place, but know that in reality, in real life, not all of these reactions would actually happen. Does that make sense? Okay? You guys know that not everything reacts together, right? Like some things you just put it together and nothing happens. All right. So my products in this reaction, sodium would come in and knock magnesium off. Now, what's the charge on sodium? It's a positive 1. What's the charge on chlorine? Negative 1. So over here, this is just going to form NaCl. And then magnesium is going to be by itself because it gets knocked off. So you get NaCl plus Mg as your 2 products. Now that is not balanced. You would have to balance it. All right. Now, what type of reaction is number 7? Double replacement, because you have compound and compound. All right, now I also want to tell you this. Not all double replacement reactions take place either. All right, and I'm going to tell you this, okay? I'm not going to expect you to do this, but in the future, like if you take chemistry, you'll be asked to predict which reactions will take place and which reactions won't take place. I'm not going to ask you to do that right now. But I just want to tell you that not all of them will take place. The only reason that a double replacement reaction takes place is if it forms a precipitate. Okay? So if you have a solid that produces out of a liquid mixture, then the reaction does take place. If not, you just got 2 liquids that are floating around together. That's it. And I'm gonna show you what happens here. If this is a beaker, I'm gonna draw this picture here. Okay, so I'm drawing a picture of a beaker. Lily, I'll upload this for you a little later. So we have calcium chloride for number 7. Just like when you did the lab yesterday, reaction number 5, where you had silver nitrate and calcium chloride, you took the 2 vials and you put them in the test tube. That's the same kind of reaction right here. So this would be a liquid ionic substance, calcium chloride. What is happening here is it's not actually calcium chloride. It's actually calcium ions and chloride ions that are floating around. So you'd have calcium ions and chloride ions that are floating around. Now you have 2 chloride ions for every 1 calcium ion. When I put potassium carbonate in, so potassium, there's potassium ion, and carbonate ions. Okay? Here's the thing. I basically have 4 ions that are floating around. I have calcium ions, chloride ions, potassium ions, and carbonate ions. Those are the 4 ions that I have from this reaction. There is also a table of solubilities. So solubility means that something will dissolve in another substance. So some things will not dissolve in water and some things will. Well, calcium chloride and potassium carbonate are both soluble in water. However, if I bring potassium and carbonate together and if I bring potassium and chloride and calcium and carbonate, there's a good chance that one of those will be insoluble, meaning that it won't dissolve in water. If that happens, those 2 ions are going to come together, they're going to clump together and sink to the bottom. And that's what you get whenever you form a precipitate. If there is no precipitate formed, all you have is a bunch of ions that are just floating around in water. So there'll be no reaction if that's the case. So I just want you to know that. Again, we're going to assume that all these reactions take place, but in the future, you'll probably be asked to identify which things actually react and which things do not react. All right. If this is a double replacement reaction, the cations are switching places. So the potassium is going to pair with the chlorine. Potassium is +1, chlorine's -1. So it's going to be KCl. Calcium's +2, carbonate is -2. So this will also be 1-to-1. So your products there are going to be KCl plus CaCO3. All right? That is not balanced, but it is very easy to balance. All right. Let's do one more, and then I'm going to let you work some on your own. Look at number 20. What type of reaction is this? You got a single compound.
Decomposition.
That's decomposition. Okay,
Number 20 or 19?
this is 20. Now, I only have 2 elements here. And actually, I don't know why that 2's right there. You can scratch that out. Okay, it's just Al2O3. All right, forget the 2 that's in the front. You don't need that. All right. This is just 2 elements. The only thing that's happening here is it's just breaking apart. Now, over here, what is aluminum? What's the symbol for it? Is it diatomic? No, it's not. So that's just going to be Al. And then what's oxygen? O2. It's diatomic when it's by itself. So those would be your products, Al plus O2, and then you would have to balance it by using coefficients. Okay? All right, anybody have any questions? Okay. I'm going to give you some time to work on some of these.